third condition is when load and source both of them are having impedance, then ZL is equal to complex conjugate of source impedance. These are the three conditions. I've done many problems on this one also and this one also. Still we have two more problems. I will be doing it. And one is from the one of the recent papers. This is a question for 8 marks in the recent papers from the paper. Is it visible, madam, here? Or can we go this side? Okay, right. So this is a question from January 2016. January 2016. Okay, 8 marks question. The question is like this. In the circuit shown in figure, find the value of RL for which maximum power is delivered, and also find the maximum power that is delivered to RL. That means we'll have to find out the RL for maximum power transfer, and as well as we'll have to find out the power. Both we should do it. Okay. The circuit is given. Circuit given is like this. A resistance here. It is a bridge network. So no need to worry about it. We have to find out the Thevenin's equivalent for this. Okay. You should be very much careful while doing this kind of problems, and by remembering and mugging all those things, don't do it. The reason why I am telling is, I'll tell you that 20 ohms, 20 amps, 120 ohms, 50 ohms. Same kind of circuit they'll give. Load resistance they'll put it here, and current source they'll put it here. Or sometimes what they do is they'll give voltage source. Or voltage source is here and resistance here. The 4 possible combinations they can give. So it looks alike. So you will think that, sir, you did in the class, no, same kind it will be there, but the position of the RL and this current source or voltage source may be different. 4 possible ways they can ask the same question. Okay. This is also repeated in many papers. Okay. Now what you should do is 20 amps. 1 minute. Sorry. Okay, right. So now what you should do is we'll have to find out this RL for this. So Thevenin's equivalent. VTH we should find out. To find VTH. If you want to find VTH, then what you do is open the load. So now what is that we are going to have? We have a current source and there is a resistance. So this is your VTH. VTH A, this is B. Okay, right. 20 ohms, 10 ohms, 20 amps, 120 ohms, and 50 ohms. Okay, right. Apply KVL loop. So this is loop. Loop current is I1. This loop current is I2, and this is I1 minus I2. Okay, right. Now start from this point. Okay, there is a super mesh here. There is a super mesh here because current source is common between these two. Therefore, this is a super mesh. Super mesh. If that is the case, from the network, what we have? From the network we have I1 minus I2. I1 minus I2 is equal to 20. Okay, right. KVL to super mesh. KVL to super mesh. KVL to super mesh. Start from this point. Minus 10 into I1. Minus 10 I1. Minus 50 I2. Minus 50 I2. And next is minus 120 I2. Minus 120 I2. And next is minus 20 I1. Minus 20 I1 is equal to 0. Minus 30 I1. Minus 50 minus 170 I2 is equal to 0. Solve these two. 1, 2. I1, I2, 1, minus 1, 20, minus 10, sorry, minus 30, minus 170, 0. I1, I2. Next. 17 amps, minus 3 amps. Okay. VTH is equal to, if to get VTH, this voltage, you have to go from B to A. You can go from here to here, or you can go from here to here like this, or you can go from here to here. Any path you can take it. 4 possible combinations are there. In all the 4 possible combinations, you will get the same answer. You can check it out. You can go from here like this, or you can go from here like this. But here you cannot go because current source is there. So only 2 possible. One is this one. One is this one. 2 possible combinations. So I'll go in the easiest path. Okay. Small values. Okay. I'll go this way. VTH is equal to, I'm going against 50 into I2, 50 I2, and against 10 into plus 10 into I1. 50 into I2. I2 is minus 3 plus 10 into I1 is 17. How much is this? $150. This is minus 150. Plus 20, yeah? VTH is equal to plus 20 volts. Next. To find ZTH. To find ZTH. ZTH is, what is that we should do? Same circuit diagram. Okay, right. Check it with what you should do. Okay, you should be very much careful while doing this kind of problem. As I said, what kind of sources are there? You should check it out. So this is what? Current source. This is a current source. Since current source, it should be open circuited. Voltage source should be short circuited. So same problem, if they give voltage source, you should do short circuiting. And what will happen, you observe carefully. When you are opening this one, because of the current source, if you are opening this one, these two will become series. But if the same problem with voltage source is there, then what will happen is, it will be short circuited. These two parallel, then it is series. So you should be very much careful while doing this kind of problem. And what source he has given, current source is given or voltage source is given. Source is given here or here. If they give here, that itself is different. The voltage source is given here, that itself is different, and series parallel combination will interchange. Carefully should do it. Okay. So this is 20 ohms. This is 10 ohms. And this is 120 ohms. And this is 50 ohms. This is A. This is B. And this is 8 ohms. Okay, right. When you see this one, when you see from this one, this is your ZTH. When you see from this side, these two will be series. Because it's open now. These two series, and then they are parallel, and they are series with 8 ohms. Therefore, what is this ZTH? ZTH is equal to 50 plus 10, and this will be, these two will be combined together 60. These two will be combined together 140. ZTH is equal, this is in series with 8 is series. These two, this and this will be parallel. This and this is 140. 140 into 60 divided by 140 plus 60, 200. 200, this 0, this 0, this 0, this 0. This is 3 times 14 into 3 plus 8. Plus 8. How much? 50, yeah. ZTH is 50 ohms. Okay, right. Now, what is that we should do? Thevenin's equivalent. Third step. I'll write the Thevenin's equivalent. Voltage source in series with the resistance, we can write it. This is 50 ohms, ZTH. That becomes Z source. And what is this one? VTH is equal to your VS. VTH is how much? 20 volts. And for maximum, this is your source. And this is your Z. This is nothing but equal to RS. And this is your RL. For maximum power transfer, RL should be equal to RS. Therefore, which is equal to 50 ohms. Find out IL. RS is equal to 50 ohms. So this is the maximum resistance for maximum power transfer. Then you find out IL. IL is equal to what? 20 ohms divided by, no need to worry about the direction here, because power doesn't have direction. So current you calculate IL divided by what is that 100. So therefore this will be 1 by 5, which is equal to 0.2 amps. 0.2 Allah? 1 by 5 is 0.2 amps. Power is equal to P max is equal to IL squared into RL. IL square is 0.2 square into 50. How much is that? 0.2 square. 0.004. 0.04 into 50. How much is that? 2 watts is the maximum. That's all for 8 marks he has asked in the examination. I think you can do this, right? Now, let us go for one more problem wherein I have not done this kind of problem so far. We did in the maximum power transfer theorem, we have 3 cases are there, and load and source both are having resistance. And second case, we have load is pure resistance, source is having impedance. And third case is load and source both are having. First case and last case we did it. Now I shall go for the second case wherein load is pure resistance, source is having the impedance. So this kind of problem, rarely they are asking, but one of the examination papers we have seen this question. Do it. So this is this question. Long back, but still they are asking this question. Right. The question is the circuit diagram. I'll write it. Minus 4J, 4 of minus 2 at an angle of minus 90 across AB. This is 2 ohms, 5 at an angle of 0 degree. Okay, you should carefully do this problem. The question is like this: find the value of the load resistance, impedance, and the maximum power transfer to the load for the network shown in figure. Also find the maximum power. Okay, right. That means you'll have to find out the power as well as what should be the RL. Okay. You see this question. When you see this question, the load is a pure resistance and source is having impedance. So therefore it belongs to second case. The condition what we should use is ZL RL is equal to magnitude of ZS. This is the condition what we should do, and then we'll have to go for the power. And we'll have to carefully should do this problem. The small twists will be there in this question. Okay, right. First you find out as usual to find ZTH. Sorry, VTH. Okay, right. Now I'll rewrite it, and rewriting the circuit with opening in the load. This is the load which is open. We'll call this one as A. This is B. And 5 at an angle of 0 is 5 volts plus minus. I'll write it. 4J, 2 ohms, and this one current source. As it is, if you want to modify, you can write it. Current source in parallel with the resistance can be converted into voltage source in series with an impedance. We can make it. Or you can keep it as it is, no problem. Let me do. What is wrong in that? Let us see with how exactly we can do with the same format. If you want, you can change it. Voltage current source to voltage source, you can convert it. And this is 4 ohms. This is 2 at an angle of minus 90 is the minus 2J. J 90 is J, minus 90 is minus J. Therefore, I can write it as minus 2J. Okay, right. So this is your VTH. We need to find out. So now apply KVL, loops, make the loops. This is your I1. Here we don't have any loop because it's open circuited. We have only one loop here. This is I2. That's all. So in between the current will not flow because it's open circuited. For a current to flow, there should be closed circuit. So this is one of the very interesting problem. So I'll start from this point. Minus 2 into I1, KVL. KVL to loop 1, KVL to loop 1. Minus 2I1, minus 4j into I1. Minus 4j into I1, minus 2 plus 5 is equal to 0. Minus 4j minus 2. So minus of 2 plus 4j into I1 is equal to minus 5. Minus you gets cancelled. So I1 is equal to 5 divided by 2 plus 4j. Point 5 minus I, 0.5 minus j. 0.5 minus j, you will get it. That is your I1. Next, KVL to loop 2. KVL to loop 2. KVL to loop 2. So no need to apply KVL, sorry, KVL to loop 2 is not required because current source in the perimeter of the, whenever there is a current source in the perimeter of the network, no need to apply the KVL itself. Therefore, from the network, what do you get it? Current, so I1 is equal to, I2 is equal to minus 2j, no? I2 is equal to minus 2j. Okay, right. Now, what is that we should do? VTH is equal to, for VTH, you'll have to go from here to here once. B to A, we should have to go once. So start from, I can't go this way, current source is, I'll have to go this way. Plus 4, against I'm going 4 into I2. VTH is equal to 4 into I2. Next, here current will not flow because open circuited current will not flow. So I'll come back here. I can go this way or I can go this way. Easiest is this one. I'm going against plus 4j into I1. Plus 4j into I1. That's all, no? I can come. So I'll have to go this way and here current will not flow. And this one current is flowing. Therefore, 4j into, what is that? I1, I can write it. So therefore, VTH is equal to 4 into I2 minus 2j plus 4j into I1. I1 is what? 0.5 minus j. 0.5 minus j. You can do it minus 8j plus 4 into 0.5. 4 into 0.5, 2 na? Plus 2j. 4j, j into j, j squared, minus 1, minus into minus, plus 4. Correct? Huh? 4 minus 6j. Is that okay? Okay, that is your VTH. Next, to find, you can do it in calculator if you don't know how to do it. To find, what is that? ZTH. To find ZTH. How will you do that? Same thing. What I will do is, I will make the sources 0 and current sources are made 0 by open circuiting and voltage sources are made 0 by short circuiting. So now what I do is, I'll take up here one resistance, one inductance, and this is short circuited. Okay, right? And this will be, current source will be open circuited and only resistance is left out, only this much. Minus 4j and this is 4 ohms, this is B, this is A, this is your ZTH and this is 2 ohms, this is 4j. Okay, right. Now what you should do is, these two will become parallel and these will be in series. So therefore, ZTH is equal to, these two parallel, 2 into 4j divided by 2 plus 4j, which is in series with minus 4j plus 4. That's all. Even though current is, for measuring the impedance, we'll have to take whole thing. So therefore, 4 minus 4j plus these two parallel. Okay, right. Now how will you do that? 8j, you calculate that. 8j divided by 2 plus 4j. Okay, right? 8i divided by 2 plus 4i. close the bracket, equals, yeah, 1.6 plus 0.8i plus minus 4i plus 4 equals 5.6 minus 3.2j na? Minus 4j plus 4. ZTH is equal to 5.6 minus 3.2j. Don't delete this one. Convert it into polar so that later on it may be useful. I don't know whether it is required or not. Okay, right? So now what is that we have? Convert it into polar. So shift complex and 3 equals. So yesterday 6.45 at an angle of minus 29.74 degree. That is your ZTH. It may be useful later. Is equal to Z source. Okay, right. Next is Thevenin's equivalent. Thevenin's equivalent. If it is Thevenin's equivalent, what is that we have? Voltage source AC plus minus, what is that VTH? 4 minus 6J. And this is our ZTH. ZTH is equal to how much? 5.6 minus 3.2J. You should be very much careful while doing this problem. That is your ZTH. It is equal to ZS. And the load is having pure resistance, RL. For maximum power transfer. For maximum power transfer, RL is equal to, load resistance is equal to magnitude of the source impedance, because in this circuit, load is having the pure resistance and source is having impedance. So we'll have to go for the second condition. 3 condition I said it. So therefore, which is equal to, what is the magnitude of the ZS? See that? ZTH is nothing but equal to ZS, I said. This is magnitude, this is the angle, readily available, 6.45. RL is equal to 6.45 ohms. That is the magnitude of the ZS, because ZS is this one. And when you are converted into polar, we got magnitude with an angle, certain angle we get it. That is the reason why I said convert it into polar. Now, so this RL is equal to 6.45. You should be very much careful. Now, you find out IL. To find IL is equal to what? 4 minus 6J complex divided by 5.6 minus 3.2J plus 6.45. How much is that IL? Four minus 6I. Okay, you'll have to put bracket. Divided by bracket 5.6 minus 3.2I plus 6.45, close the bracket, equals 0.433 34 ಅಂತ ಹಾಕ್ಕೊಳ್ಳ 33 minus 0.383 J. Convert it into polar. Shift complex 3 equals 0.578 at an angle of minus 41.43 degree. There itself you do it. Okay. There is an advantage if you do like this, so that your calculation become very easy. Okay. Power is equal to what? P max. P max is equal to magnitude of IL square into RL, we said. Whenever complex value is there, you have to take the magnitude of it. Magnitude is readily available. What is that value? 0.578 whole square into RL. RL is how much? 6.45. How much is that? 2.154 watts is the maximum power transfer, P max. That is the one we have said. And what is the maximum value of RL? This is the answer what we are expecting, right? So that's about the problem on the second case what we had. So 2.154 is the right answer. Okay. Well, let us move on to a few more examination problems. Let me see what and all they are asking. Okay, right. So same kind of problems we have seen in many papers. Okay, right. Still, let us see what and all they asked in different papers. And other paper, a state maximum power transfer theorem proves ZL is equal to Z naught star. So that means third case we should prove it. Okay. Norton's Thevenin's power transfer. Okay, once again, state and explain maximum power transfer theorem and load impedance consisting of the variable resistance and variable reactance. That is third case. So only derivation he has asked. Okay. Yeah. So this is the question from July 2014. Another easy problem. Okay, right. So now we have a voltage source plus minus one resistance, 8 ohms, 5 volts, one more resistance with current source parallel, and a resistance with a voltage source plus minus, and this is the load resistance, and he said it is RL, A, B, 2 volts, 4/3 ohms, and 2 amps, 4 ohms. Easy question this is, of course. Find the value of load resistance when the maximum power is transferred across it, and also find the value of the maximum power transferred for the network. That means we have to find out the RL as well as P max. 8 marks question. This is a 8 marks question in July 2014. July 2014. Okay, easy question. So first is, as usual, to find VTH. If they're asking power, we'll have to find out VTH. If the power they're not asking means, just we can find out directly ZTH. Okay, right. Now what is that we can write it? So find out the VTH. To make the circuit easy, what you can do is you can convert current source in parallel with a resistance can be converted into a voltage source in series with resistance. You can do it anything. Anyhow, you have to find out VTH. How you are doing it, that is left to you. Plus minus, this is A, this is B, 2 volts, 4/3 ohms, and plus minus 4 ohms. V is equal to I into R, 8 volts, 8 ohms, 5 volts. Okay, that is your VTH. Okay, right. So now from A to B we should go. First you apply KVL. I. Okay, right. KVL. Only one loop is there. Minus 8I, minus 8, minus 4I, plus 5 is equal to 0. Minus 8I, minus 4, minus 12I, minus 8 plus 5, minus 3. Transfer to right hand side, plus 3. So this is 4. So therefore, I is equal to minus 1/4, minus 0.25 amps. Okay. VTH is equal to what? you go from here to here once. I'll go this, or you can go this way also. Both are on the same. Voltage source, current source. Voltage source resistance is there. I'll start from here. 4 into I. Against I'm going 4 into I. Minus 2 plus is plus 8. Now I'm going here, but no current is flowing through this one because of the open circuit. But voltage source will be there. Plus 2 minus is what? Minus 2. Therefore, VTH is equal to 4 into I. I is what? Minus 1 by 4. Plus 8. Minus 2. 4, 4 gets cancelled. Minus 1. Minus 1, minus 2, minus 3. Minus 3 plus 8 is 5. Huh? Plus 5 volts, you will get it, VTH. Next is to find ZTH. Okay, right. Same thing will be there. Resistance. One more resistance. And voltage source is shorted. And if you are keeping current source, that is open. Both are on the same. You get same circuit only. Okay, right. And this will be the resistance here. And the current source will be short circuited. 4 by 3 ohms. 8 ohms. Oh, this is short circuit, 4 ohms. This is your ZTH. ZTH is equal to 4 by 3 is in series with the parallel combination of 4 by 3 plus 8 into 4. 8 into 4 divided by 12. So this is 3 times 8 by 3 plus 4 by 3. That means 3 8 by 3. 3 8 by 3 is nothing but what? 8. Correct? Huh? Because 4, how I am calculating is 4 by 3 is nothing but 2 8 by 3. 4 by 3 is nothing but what? 4 by 3, we can write it as what? 2 8 by 3s. Correct agutta? 4 by 3. Correct agalva? 8 by 3. Answer ಎಷ್ಟು ಬಂತು ನೋಡಿ ಮೇಡಮ್? 4 by 3 is 12 by 3. Okay, right. Answer 4 barte correct. Sorry. This is 4 ohms. Four by 3 is nothing but equal to 8 by 3 plus 8 by 3. Am I right? That's what I wrote it. 2 8 by 3s. That's what I said. Plus, what is that we have? Plus 8 by 3. So that is nothing but 2 8 by 3 plus 1 8 by 3. That is nothing but 3 8 by 3. Wrong. 3 8 by 3 ಆಗುತ್ತೆ. 8 ಆಗುತ್ತೆ ಆನ್ಸರು. LCM 3. 8 by 3 plus 4 by 3. LCM 3. 12. 4 ohms. Correct. Okay, right. Anyhow. So 8 by 3. Okay, I'll write it here. 1 minute, I'll check it out. 8 by 3. This 4 by 3, I'll multiply by 2 in the denominator and 2 in the denominator. This is 8 by 6. Okay, right. You can do it as calculator only. 4 ohms. Now ZTH is equal to 4 ohms, which is equal to your RS, source resistance. Okay. So plus minus source resistance. Sorry, source. This is equal to how much? 5 volts. This is how much? 4 ohms. For maximum power transfer. Maximum power transfer. What is your condition? Because here in this case both load as well as source is having resistance only. Therefore RL is equal to RS. So because see this load is a pure resistance. Source having only resistance. So therefore 5 ohms. Sorry, resistance 4 ohms. Okay, find out IL. IL is equal to what? 5 divided by 8. How much is that? 0.625 amps. Pmax is equal to IL squared into RL. IL squared on the 0.625 square into RL is how much? 4. It is equal to how much? 1.562 watts is the Pmax, maximum power transfer. Okay. So that's about the rest. This kind of problems are concerned. Now let me see if time permits. I'll do one more problem. That is from 2014. Now let us move on to any other problem is same kind of one more problem is the 10 marks. So here in the 10 marks, the question is like this: state maximum power transfer theorem. Only statement that will fetch you 2 marks generally. For the circuit shown in figure, what should be the value of R such that maximum power transfer can take place from the rest of the network to R? Obtain the amount of this power. So that is a 10 marks question in the examination. Problem will fetch you 8 marks and statement will fetch you 2 marks. Okay. So this is a question from January 2014. Easy question, of course. Okay. This is 10 marks. January 2014. 10 marks. Statement will fetch you 2 marks. Only problem will be 8 marks. The question is like this. Very easy one, of course. He said this is R. This he called as A and B. And here he said one resistance and one load. Similar to the last problem only. Plus, minus. Very easy one. 24 volts, 10 ohms, 5 ohms, 2 ohms, 5 amps. Okay, right. Okay, right. So now what is that we have? So find VTH. To find VTH. Now you make it open, this one. This is your VTH. So current source in parallel with the resistance, I can make it as a resistance in series with a voltage source. And this one, you keep it as it is. Plus minus 24 volts, 10 ohms, 5 ohms, and this is 2 ohms. V is equal to I into R, 5 into 2, 10 volts. Okay, right? And here open circuit, no need to apply KVL, only one KVL is there. I. Okay, right? KVL to the loop. What is that we have? Minus 10I, minus 24, minus 5I, you will get it, is equal to 0. Minus 15I is equal to 24. I is equal to how much? 24 divided by minus 15. How much is that? 1.6. Correct again? Okay, amps. Okay. VTH is equal to go from A to B to A, B. Go from here to here. So you can go this way, the easy path. What is that way? Against 5I. VTH is equal to 5I. And next, when you're going from minus to plus is plus 10. Plus 10. No current flows because of the open circuit. So therefore, VTH is equal to 5 into minus 1.6 plus 10. How much is that? 2 ohms, 2 volts. Next, to find ZTH. ZTH andre open circuit. This is resistance. Your voltage source is short circuited, and this one we have, and this is also short circuited. So this is your ZTH, and this is 2 ohms, 5 ohms, and 10 ohms. And if you see this ZTH, this is in series 2 ohms, these two parallel. 2 plus 10 into 5 divided by 15. So 3 times. The 10 by 3 is 3.33 plus 2 is 5.33. Correct, madam? 5.33 ohms. That is your ZTH. Next is Thevenin's equivalent. Thevenin's equivalent. What you should do? A voltage source in series with a resistance. Okay. And there is a load RL. RS is your ZTH, which is equal to how much? 5.33 ohms. And the VTH is how much? VTH 2 volts. Sorry. Okay, right. For maximum power transfer. What is the condition? RL is equal to RS, which is equal to 5.33 ohm. So find out IL. IL is equal to 2 divided by 5.33 plus 5.33. Both series. So how much is that? 2 divided by 10.66. 0.187. 0.187 amps. P max is equal to what? IL squared into RL. IL squared is what? 0.187 whole square into RL is 5.33. How much is that? 0.187 whole square into 5.33. 0.1863 watts. ಅಷ್ಟೇ ಬರ್ತಲ್ಲ? Okay, right. So which is nothing but equal to 186.3 milliwatts. 186.3 milliwatts we can write it. That's how we should do it. So that's all about the maximum power transfer theorem. Next class I will be talking about a small theorem, that is your Millman's theorem. Okay, that will be the end of this module. Okay, I'll continue in the next class.